So on this worksheet, we're looking at some open intervals of increasing and concavity. Okay, so increasing, that means our y values are getting larger. Okay, so that looks like that happens from this point on the graph, right? This is on the graph, the places where the y values are getting larger. Okay, now an interval always comes from your x-axis. So these are the answers that we're going to be looking at, the x-axis intervals. So open intervals means parentheses. So this graph is increasing from -3 to +3. Okay? So open intervals is given to us with parentheses. Now the second question is, on what intervals is it concave down? So this one we're going to have to guess a little bit and make your best educated view. I think maybe it starts being concave down at 0. Right? I think that would be a pretty okay estimation for where it's concave down. If you said at +1 or if you said at -1, that's okay also. What is this? 1, 2, 3, 4, 5, 6, 7? 0 to 7, this graph might be concave down. So depending on where your starting point is, where you think the point of inflection is, right, that's going to be your interval. And maybe it's a little bit different than mine, but that's okay. Okay, depending on how your eyeballs are seeing this graph. Okay, on what open intervals is G decreasing? So for decreasing, we're looking at y values going down, right? Y values getting more negative. So it looks like it happens here. The y values are decreasing, right, to the bottom of that graph. And then again from this max to that min. So I would say that there are 2 intervals on this graph where it's decreasing. Because it has a parenthesis, we're going to start at negative, not a parenthesis, but an arrow. Right, that arrow goes off there. So we're going to come in from infinity to -3. Right, that's our first interval where we have a minimum value where it stops becoming decreasing, and then we pick it up again from 0 to 2. This is our other interval where our graph, our y values are getting smaller than they used to be. Okay, so 2 intervals where our graph is decreasing. And then on what interval is the graph concave up? So once again, it really depends on how your eyeballs see things. My eyeballs might see concave up until we get to -1. Okay, so from -infinity to -1, I'm saying that that graph is concave up. And maybe you put at -2 or -1.5. Okay, and then looks like to me the graph starts becoming concave up again at +1. Okay, so I would say the graph is also concave up from +1 off to infinity because of the arrows. Okay, if you stopped at +5 there, if that was the end point of yours, that's okay also. We hadn't talked about what the arrows mean anyway. Okay, so that would be the open interval where we're decreasing, where the y values are getting smaller from your graph, and then concave up where it looks like a cup, right, an upward facing parabola. Okay, number 3. Now this is a very strange graph. This is a rational function graph. Okay, it has a horizontal asymptote and a vertical asymptote. And it's saying from -5 to 7. So we're only looking at the range from -5 to 7. Okay, not the entire graph whatsoever. So on what intervals is it increasing? Well, being a rational graph, every one of these y values is a little bit bigger than every one of it before. So it's increasing from -5 to this asymptote, right? So our y values are getting big really fast there. But then at +2, it's not defined. That's why we have that asymptote there. And then it's increasing again, right, for the rest of the graph from 2 to 7. The y values are getting larger, right, a little bit larger every single one of these for the whole entire thing. Okay, so that would say anytime we have a rational function, usually it's always increasing all the time. And then for what one is it concave up? Okay, it's concave up over here on the left side, right? This is not exactly look parabolic, but it is increasing, right? So concave up from -5 to 2. And then on the right side, that graph is all concave down. Okay, I apologize for the blurry vision. It's my recording device here. My iPad gets worse as it tries to optimize its memory usage. So we can't even read what this one says, but let me tell you, it says on what intervals is the graph both increasing and concave down. So we're looking for increasing, where the y values are getting bigger, increasing, and concave down. So let's think about our concave down graph. Okay, so there we have our concave down graph. And we're going to divide it into two. What side has y values that are increasing? The left side. So we're looking for the left side of a concave down parabola. Okay, so it looks like the left side of the concave down parabola might go from, what is that, -7 or -6 to -3, I believe, is that x value right there. Okay, so increasing at a decreasing rate. Decreasing rate means that we have a downward facing parabola. Increasing means it's the left side where the y values are getting bigger. Okay, and the next one says, where is it decreasing and concave up? So think about our concave up graph, and we'll divide it into two. What half of the concave up graph is decreasing? Right, the left side is a decreasing concave up graph. So maybe that happens from, looks like maybe 0. Is that kind of what you're thinking? That this is the decreasing part of our concave up graph? So from 0 to maybe, is that 3 on a nice looking sheet? Okay, decreasing side versus the increasing side of your concave up or concave down parabola. Okay, that's going to be a pretty important thing as we come over here to our other questions, which I'm going to stop and make a new video for.